Hello, this is Jason, and today I will be doing problem number 68 in section 9.7. This question is a three-parter, and it's basically asking us to look for some patterns. So I'll be doing this on Paint. Wait a second. Alright, okay. So the first part of the question says to differentiate the Maclaurin polynomial of degree 5 for f of x equals sine x and compare the result with the Maclaurin polynomial series of degree 4 for g of x equals cosine of x. Now, since these are basic functions, we already have an established polynomial for these. For sine of x, it is sine of x. Oh, Lord, that is horrible. That is equal to x minus x cubed over 3 exclamation mark plus x to the 5th over 5 exclamation mark. And I know that it's not called exclamation mark, it's called factorial, but I just feel like doing this. Minus x to the 7th over 7 exclamation mark plus x to the 9th over 9 exclamation mark. And of course this is asking us to do it to the 5th degree polynomial and to compare it with the 4th degree polynomial for cosine of x, which is equal to 1 minus x squared over 2 exclamation mark plus x to the 4th over 4 exclamation mark minus x to the 6th over 6 exclamation mark plus x to the 8 over 8 exclamation mark. And of course, we differentiate this sine of x, and we already know that derivative of sine of x is equal to cosine of x. And then so we take the derivative of this polynomial right here, expecting to get the same answer. And it is. You see, when you differentiate x, of course, that's the 1. And when you differentiate the x cubed, the 3 goes down. Like, the 3 is brought out to multiply by 3, eliminating the 3 from the beginning of this factorial, making it 2 factorial, while the power is reduced by 1, so that's x squared. And then for the rest, it's, well, basically the same. This becomes x to the 4th. This is multiplied by 5 in the coefficient, and then the 5 here is canceled out, so that's 4 exclamation mark. And it's the same, it's the same, and it's the same. And then we find out that, well, it's the same derivative, basically. I mean, it's basically the same as cosine of x when you derive the power series for sine of x. Alright, the next part is to differentiate the Maclaurin polynomial of degree 6 for cosine of x and compare the result with the Maclaurin polynomial for degree 5 of sine of x. Alright, so let's write out some more terms, I guess. Plus, oh, that's not a plus. I need to erase this right here. Burp, erasing in progress. And then minus x to the 10th over 10 exclamation mark plus x to, oh my lord, plus x to the 12th over 12 exclamation mark. And let's see, this one is to the 5th power, so that would be plus x to the 11 over 11 exclamation mark. Oh, that doesn't even look like that. Looks like 121. Alright, so, well, we're deriving this, and then this becomes 0, this becomes negative x, and this negative x comes from the fact that the 2 is brought down, 2 and the 2 cancel out, 1 exclamation mark is 1, so that's just negative x. And if you keep on doing that, you'll realize that it's basically the same as derivative of cosine x is basically the same as sine of x, except that the signs, like not this sign, but the signs are reversed. For example, the first term is negative x when you take the derivative of this, of course, and this is x. When you take the derivative of this, it's x cubed over 3 exclamation mark, while this is negative x cubed over 3 exclamation mark. Keeps on going, negative, positive, positive, negative, negative, positive, positive, negative. And basically what it's proving is that the derivative of cosine x is equal to the negative derivative of sine of x, which is what we would expect. All right, now finally, the last part of the problem asks us to differentiate the polynomial of degree 4 for e to the x. And for that, it's 1 plus x squared over 2, over 2 exclamation mark, plus x cubed over 3 exclamation mark, plus x to the 4 over 4 exclamation mark. Oh god, that 3 is horrible. Alright, so once I take the derivative, it's like, what do you notice? Well, you see, if you take the derivative, it's just, that's 0, and this is 1, this is x squared, this is x to the cube, with the same principle as before, because you bring it down, cancels out with the first multiplied thing in the factorial, and then it leaves 3 exclamation mark, 2 exclamation mark, 1 exclamation mark, etc. And then, so basically what you get is a Maclaurin polynomial for e to the x, except with a power of 1 less. And that is it for the 3 types of things that we'll be doing.